We use chemicals to get a stain out of the couch, keep worms out of our apples, and even attract a mate with the right perfume. But possibly the most important chemical reaction is happening all of the time in plants, as plants convert chemicals from the air into chemicals that feed all living things, sugars. By doing photosynthesis, plants play an important role in the food web. As you can see, this plant has been eaten. But we know intuitively not to eat that plant. Why is that? Plant defenses. We, like all other living things, make our decisions about what to eat or what not to eat based on plant defense chemistry. Spicy food, coffee, mint, even the nightlock berries, fictitious in the Hunger Games that ended the whole thing, play an important role in those food choice decisions. So in this way, plant defense chemicals can mediate an entire step in the food web between producer and consumer. So understanding how, when, and where plants make more or less or rearrange those plant defense chemicals into different patterns can be pretty important to understand ecology. I aim to do this using lima bean, a plant you may or may not love, but don't eat them raw. This is because lima bean are one of the many plants that can make toxic cyanide as a defense. Now, I wanted to know, how does this cyanide change when the plant is maintaining a symbiotic relationship, one that is famous in bean plants, with nitrogen-fixing bacteria? These bacteria take nitrogen from the air and they give it to the plant in the form of fertilizer that the plant can use as nutrients. And so with these extra set of nutrients, I expected that plants would be able to make more defenses, which was true for cyanide. But as anyone here that maintains a relationship with an advisor may know, even the best relationships require energy and resources. And in this case, up to 30% of the plant's sugars were dedicated to keeping those bacteria alive in root nodules, which limited the sugars that the plants had left over to secrete a sugar, a nectar, that would attract aggressive ant bodyguards that would otherwise protect that plant. So here we have a change in defense pattern, but because of this beneficial relationship. So it is not just the plant-insect herbivore interaction that is driving these plant defense patterns, but we also have a whole suite of beneficial interacting relationships that the plant is constantly navigating. So we need to understand those relationships and consider them in order to predict how, when, and where will plants defend themselves. Because only then can we begin to rely more on those defenses and recruit more of those natural predators in order to use less of those harmful pesticides that, rightfully so, give us that negative connotation that we have with the word chemicals. Thank you for your time.